This meeting is being recorded.
All right. Today is Wednesday, January 12th, 2022. This is the Kubernetes Data Protection Working Group. Today there are two main agendas. One is that we're going to continue the discussion that nice presentation Xiangqian gave last year, a month back. After that, we will discuss a couple of open issues. Xiangqian, I saw you are already online. Let me know whenever you are ready. I think Xin has already made you the presenter.
Yep. Sorry, silly question. When I hit share screen, it shows me a whiteboard setting. This thing worked last time. Does anybody know?
Oh, let me. Okay, so let me see if I made the right Sean the presenter. Let me double check and see if you are actually. Yeah, I see that says co-host next to your name, so you should be able to share your screen. All right, now.
Yep.
No, I'm not sharing my screen. This is something called a whiteboard, which is what comes up on
okay.
my share screen. Just trying to figure out what I'm missing.
Okay. When
do you
I
have
click,
multiples? Do you have multiple screens? Maybe sometimes, maybe.
Oh yeah. Okay. Yes, I do. Let me. Give me a second. Sorry. Fix my multiple screen issue. Okay, let me try again.
I am not seeing your screen so far.
Yeah. I'm not seeing an option to share the screen. I'm just seeing an option to share a portion of the screen.
That's very. So you want me to share? Is that?
Yeah, I can share as well if you want.
Okay.
Yeah, sure.
It says started sharing.
It's a weird option which says.
But okay, all right. Maybe Xiangqian, you try to share.
Yeah, I can share.
Thank you.
No problem. Okay, let me find out.
Show me, this is the one?
Yes.
Okay.
All right. So let me start by. So I just had some notes from the last meeting, just so that we can get warmed up, I guess. So initially we did discuss about grouping volumes for replication as well, and got out the point as to being prescriptive about that. So I just wanted to reiterate or repeat that we would replicate either PVCs or volume groups, and the grouping really comes from volume groups that's in flight. The proposal is in flight, and I don't see us doing replication groups as such as something separate from volume groups. But does that conflict in any way based on the discussions last time we met?
I'm sorry, are you saying in this updated slide deck you will be talking about using volume group?
No. So let me. No, not necessarily volume groups. So we did talk about when we talked about the orchestration. Ben was talking about instead of only considering PVCs, we should probably out of the gate have something for volume groups. and I was just trying to repeat the notes from the last time, saying if you have volume groups, we expect volume groups, grouping of volumes to come from the volume group enhancement proposal and not
Right, that's
from-
another proposal.
Yes.
I think we still need to have individual volume replication. So I think we will need both anyway. So can you just continue with whatever you discussed in the last meeting?
Okay.
The volume group replication, that's there's a tab that I'm working on, but that replication part is kind of like the second part of that whole thing, right? Because we're trying to address the group snapshot first.
Exactly, correct.
So yeah, why don't we just go through this one first?
Okay, so let's probably skip to slide 14, or maybe slide 14. Right. So we talked about the various the common goals in terms of storage, in terms of pairing storage systems for mirroring, and talked about roles across these storage systems for individual volumes, being primary and secondary, and replication of data happening from the primary to the secondary, or at least the primary is writable and the secondary is the copy of data, snapshot-based copy of data, or otherwise, however the storage system decides to do it. Then we talked about failover and failback and how to orchestrate that. We did start talking about how the solution looks. So I just want to start off from there and continue forward. So before we talk anymore, there are some caveats in what we're presenting. There are some assumptions. For example, this does assume 2 or n-way replication. It also assumes that the storage systems can talk to each other across their control plane, and that's not orchestrated or done via cube. In other words, if we request for a volume or an image to be mirrored, replicated, the setup can be done from the east storage cluster onto the west storage cluster. It doesn't have to be done via cube on west, and then you come back on the east cluster and redo the storage peering as such. The final assumption, which is something we have, but we don't want to really take it forward, is that it assumes that the volumes are accessible via the same CSI volume handle across these two peer storage systems. So we're basically talking about what we've done to set the stage for what can happen down the line. Moving on to the next slide. So what we added here is a CSI sidecar to watch and reconcile volume replication CRs, cluster resources. Volume replication cluster resources pretty much point to a PVC, and hence via the sidecar talk to extended gRPCs on the storage provider to enable disable volume replication for that particular volume. As I said, it's assumed that the storage is already set up or peered for replicating images. So that's out of scope of what volume replication does. Very simply, there is a replication class which has details about, like the storage class has details about the clusters that appeared and parameters that are vendor specific and so on. The volume replication itself points to a replication class and then points to the data source, in this case, PVC. And it's a data source because later on, when volume groups come in, it can point to a volume group and say, I need volume replication for the entire volume group, and not per PVC as such. And it has a replication state which is flips between primary and secondary as the need case may be. Going on to the next slide.
So I hate to
So-
interrupt so early, but I'm just curious why the decision that the secondary volume is implicitly created rather than explicitly created.
Okay, so if we start, how should I put this? Okay, so if we are going to create the secondary volume using cube resources, let's say a PVC, we actually, and the application only runs on one of these two clusters. So we will have not necessarily orphaned PVCs, but PVCs that are no longer user managed in that sense. So the user is typically managing the application and PVCs on the current primary cluster for that application. And now if the user is expected to go around and to the secondary cluster, create PVCs, and then provide, which will hence create images on the volumes on the secondary cluster and hence provide the information back and forth between these clusters. The responsibility of the app user becomes managing PVCs across these two systems where it's in use in one side and not in use in the other. The second observation or need there was the storage systems are already peered. So the question is usually the data plane's peered and the control plane's not. But going to CSI, if the control plane information of the participating clusters is available with the CSI plugin, it can proxy instead of the user to create the required volumes on the secondary end. They have no representation in Kubernetes, so when a primary volume is garbage collected on the primary Kubernetes instance, again the CSI plugin can actually proxy for the control plane of the secondary and garbage collected on the secondary. Makes it much easier to deal with, make it simpler for the user to deal with PVCs and pods using those PVCs on a cluster rather than actually having to handle this across clusters.
Right, but in a disaster, what does the user do?
Yes.
I mean, if you're going to get to this later, maybe I should postpone my question. I don't want to.
No. We will get to it in a minute because I did add 3 more slides based on the tail end of the conversation last time as to the orchestration that the user has to do. So we'll get to it in a minute. Let's do that.
Okay. Proceed then.
Yeah. Can we move on to the next slide, please? Thank you. I talked about the volume replication class. It's a very basic definition here of a volume replication class and everything else stuffed into parameters. We're typically looking at replication schedules as one of the more common parameters here, and everything else being vendor specific as to what's the cluster ID that's peered and so on, so that whatever validation needs to be done can be done. But we just wanted the schedule out so that the users cannot, all users, it's kind of resource controlled in a particular way because the volume replication class would become a cluster scope resource and hence can be quoted. And so every user does not end up asking for a replication schedule of 2 minutes or 5 minutes or a minute. And we can have classes of users who are allowed to request replication based on different scheduling intervals. Anyway, that's the replication class. Can we move to the next slide, please? Right, so this is a brief of what we were talking about, what the user needs to do. We'll talk about it again a little bit. So when the failover has to happen, the user needs to create the volume replication cluster resource on the secondary cluster, set it as primary, and use the same data source as they used on the east cluster and pointed back to the same PVC. And then when they bring the PVC, when they roll out the application, which includes the PVCs and pods, the volume replication resource would be able to recover from mark the actual volume on storage as primary. But here's where one of the caveats which was introduced was that we depend on the CSI volume handle to be equal on both clusters, or in other words, as long as the PV object is the same across these two clusters, it's assumed that the CSI plugin can map it back to the mirrored copy of the volume on the storage system on West.
Does that have to be a requirement? Because not every storage system can do that, right? So maybe that's true for some, but not for everybody.
That is correct. We would actually want to remove that requirement. We can. So what we instead want to do is, so there are two problems. That is problem A. As a matter of fact, even for Ceph, we had to do some level of handle mapping across clusters to ensure that we map to the mirrored copy on the remote cluster, on the secondary cluster. But barring that, it also means that a cluster scoped resource like the PV has to be backed up and restored onto the secondary cluster, which a user cannot do by themselves. So it's not controlled by the user any longer. The cluster admin or has to step in to back up and restore the PV. So that's also not good. So we don't want to go down that path, but that's where we started. So that's why it's represented as such. What we instead want to do is, when the volume replication is initially created on the east cluster, there has to be some cookie information that goes from east to west. So when the volume replication is created on the east cluster, it establishes the volume for replication, it spits out just like the CSI volume handle. Let's just call it a CSI replication handle. Spits out the CSI replication handle, which is what we use to create the volume replication resource on the remote end, and create a PVC from volume replication as the data source. In which case, the user can take the replication handle and reuse it on the other cluster, pre-deploying the PVC and the workload.
So, so everything you just said, I agree with. That you need some sort of cookie that can be transmitted from one cluster to the other cluster. But it sounds like you said the current design involves like some administrator backing up the PV, and you don't like that because you would rather have a self-service kind of a model. And doesn't that get you back to the point where the user should be creating a PVC on the secondary, so it's self-service and not administrator controlled?
So I didn't draw out that model. So let's, the user does have to create a volume replication resource on the secondary and feed it the cookie that they got from the east cluster.
Mm-hmm.
And the PVC will have a data source of volume replication. So it'll
Okay,
iterate.
okay, so they can create their own PVC and point it at some object which points back to the original cluster implicitly, and then and that PVC will pop up with the correct data from the mirror relationship.
Right.
Okay, but you wait until it's time, until after the disaster has happened and you want to do the failover, and then you go and create that PVC pointed at the relationship and set it all up.
That's correct. Yes.
Okay, and then okay, and then you're going to get to how you reverse things and get it back into replicated state after the disaster ends.
Yes.
Okay.
I'm going to get into it.
All right, I'll wait for that.
Yeah. Right. So we, the next slide is just about ordering. In the PV-based model, in the vol rep cookie-based model, you'll create the volume replication resource first. But as long as your PVC definition is updated to use a data source of volume replication, it'll either fail to get provisioned on west till the volume replication resource is actually created, or it'll provision as soon as the volume replication resource is available on the west cluster. With the PV-based model, we have an ordering constraint, whereas with the volume replication cookie-based model, we will not have the constraint. With the PV-based model, we have the constraint because if we create the PVC, if we don't create the PV with a required claim ref for the PVC will just go through dynamic provisioning and not get the required data because the storage system wouldn't know where to get the data from. So in the PV-based model, the PV has to be restored first, which is another sort of not a good thing from a design perspective to actually depend on PVs and CSI volume handles to reattach storage on the West cluster. Let's go down to the next slide. Okay, so these are things that I added. This gives here's where we talk about some of the steps that the user has to do when they deploy the application, which is this slide. The next two slides will be about when they fail over the application, when do they fail back the application. Some of it is a repeat, so I'll try to see if we can go through this faster. So when they deploy the application resources initially, they deploy the pods and the PVCs, but additionally they create volume replication per PVC as primary. And yeah, of course, step 3 is ensure that the volume replication is primary, and then out of order step 4, which is all the way at the bottom, is to protect the PVs, protect the PV cluster data from the East cluster, which again, let me repeat, the user cannot do because it's a cluster scoped resource. But that's where if it was a volume replication cookie, the user would have been able to protect this cookie at present. Step 5 is keep watching for any new PVCs in terms of stateful sets and other such things. But that's a higher level orchestrator issue in the sense, as a user, if I'm using a stateful set and I scale it up, I get newer PVCs, which means I need to create newer volume replication resources for those PVCs. Whereas if there was some higher level orchestrator which grouped this, it would probably automatically start protecting or replicating those PVCs as well. But as a user, as it stands, if there is dynamic PVCs appearing on for the same workload, they'll have to keep creating volume replication per PVC for that particular workload. Moving on to the next slide, which is about failover. Again, part of it is a repeat, but we'll just go through this quickly. Step 1 is East becomes unavailable, which is a disaster, and so now we need to move it to West. So the first thing, here's where the ordering is important. We first need to restore the PV cluster data onto the West cluster so that the claim refs point back to the PVCs that were created. Step 3 is you redeploy the application resources, which comes with the pod PVC and volume replication resources that were created on the East cluster. We create the PVC as primary, which tells the storage that the corresponding image has to be force promoted to primary because there's already an existing primary, but we don't know its state. Once East is available, here's where we start talking about heal and fail back. Right? Once East cluster becomes available, the user would have to delete the application resources on the East cluster and also also update volume replication as secondary so that the resync can start, because that will let storage know that the local volume on the East cluster has to be a secondary volume, and it either flips the replication relationship, but because this is a failover, it would have gotten into a split brain issue, as in it may have received some IOs which are out of sync from West, and so, well, storage decides whether it needs to resync the volume from a last known good snapshot or just continue resyncing from where the current primary is. But that's the point at which that decision is made. And once we know that the volume replication resource is resyncing, we can delete the volume replication resource and clean up all resources from the East cluster. And moving on to the next slide. When we need to relocate or fail back the workload to the East cluster, well, we kind of start with ensuring that the volume replication resource is primary, yes. Delete all the application resources, which basically means the PVC gets deleted, the pod gets deleted. This is important so that we can ensure the PVC is not in use before we flip the volume replication. Volume replication resources also change to secondary, but before we act on that and tell storage to change it to secondary, we need to be sure that the pods are not there are no pods using the PVCs, and that the PVC is deleted, so there cannot be an out of order pod creation that will use the PVC as we are marking it secondary, which is step 3, and then we go to step 4. And once we mark it secondary, the user will have to ensure that the final sync is complete, and then delete the few more steps in the previous slide. can we go back to the previous slide, please? Thank you. User will have to clean up and delete all the volume replication resource as well, which will garbage collect the PVCs and other such things, and then redeploy the resources on the east cluster, marking volume replication as primary. Of course, there is a step 7, you have to restore PVs before you recreate the PVCs on the east cluster. So Ben, you had a question on failback.
Well, yeah, I was just trying to understand like how, what the user actually has to do. And so it sounds like every time you want to do a failover and a failback, there's creating of new PVCs and deleting of old PVCs, and manipulating of these relationship objects, right?
That's right.
Okay. How about like a planned failover?
So a question I have on planned failover is, does the secondary start off from a snapshot of the data or not?
I mean, ideally it has the latest copy, right? But the reason I bring it up is because in my experience, like people that are serious about disaster protection exercise their disaster recovery plans regularly, even when there's not disasters, because you never want to be in a situation where you try it after the disaster happens and find out it doesn't work, right? So it's important, as far as I'm concerned, that there's a way to initiate a failover just when there's no disaster, to exercise the works and make sure that it's all, all the machine is working basically.
Okay.
And so in the version of this that we've implemented, like the PVCs just hang around. We don't delete them and create them. So I'm trying to understand what the advantage of doing it this way is, where you're creating and deleting PVCs every time you want to fail over and fail back.
We want to associate the PVC lifecycle with where the app is primary, than associate the PVC lifecycle with where all the app can be primary, where all the app can run. That's why, if I have to state it in those words.
Okay, so
let me ask a follow-up question here. So for you to delete the PVCs, obviously all the PVCs have a finalizer, for protection. So that means no pod should be mounting those or using those PVCs. How are you managing the apps? Whose responsibility is to delete the apps?
So although I've posted it here as the user is responsible to delete the apps, so without any other multi-cluster orchestrator, the user is responsible to delete the apps. The app user.
Okay, is that realistic in on-the-roll scenarios? Because imagine if you have a network outage or something, user may not even reach the cluster. Or, if you, previously you said you don't want the users to manage PVCs on the West cluster because there was too much of a manual process now, but they have to delete the apps on the East cluster now.
Yes, okay. So you're right that they cannot delete the app on the East cluster as long as it's unavailable. But once the East cluster is back up, they would have to undeploy the app from the East cluster.
Okay.
Right. In a regular case, in a normal scenario, what will happen is if the app continues to run on East, there are a few things that will happen, right? Okay, the volume still noted as primary. Okay, so technically the storage system would actually allow IOs to storage rights to storage.
Right.
But who is actually using the app? Where are other applications that are using the capabilities of this particular application, requests coming from, that can be in cluster or out of cluster. In cluster apps that continue to run would continue to send requests, but it really requires some level of global traffic management or rerouting of the app's external addresses to the West cluster. So the app has to be deleted at some point in time in East. Right.
I guess the issue is this, like once, I guess you can protect the new primary on the cluster, on the West cluster, by breaking the peering relationship, right? But once the East cluster comes back up, obviously IO would still go to the PVs there. This wouldn't affect the new primary, but it can affect the old primary. And I guess, I don't know, based on maybe the type of storage backend you have, that can have implications on resync. So if you want to switch back to making the East the new primary, that can have implications there, right? But
That's correct.
that can also have implications on, I guess, customer facing, because somehow, I mean, basically the whole solution hinges on the fact that some load balancer has to direct all client traffic now to the West cluster and nothing goes to the East cluster.
That's right.
You mean in like a network partition situation, or?
In a network partition situation, or even if for a plan migration, you still want to direct all new traffic to destination.
Yeah, I was just saying, like in an actual outage, if the load balancer is pointed to the wrong place, you just don't get anything, right?
But as soon as like East cluster comes back up, load balancer would treat that as a legit backend. I would send traffic there.
Yeah. I mean, it's something that needs to be managed for sure.
Yeah, the load balancer should not, I mean, it should be managed to not send traffic east pre-failover to west. I think 10, 12 slides ahead, we said that we're not dealing with the load balancer or traffic redirection in this set of slides because it's sort of external to storage as such. But yes, the load balancer will have to divert traffic to west and not discontinue using east.
Okay.
So,
yeah.
Right. Going back to the failover testing, right? I mean, and if so, failover testing is one form of failover testing is no different than the relocate, which is provided in this particular slide, which is a coordinated handoff of the application from east to west. Which is why I asked the question.
There's a question from Xiangqian. He could not unmute himself. He has a question in the chat. In a DR scenario, east is not reachable. How would you operate against it?
Right. So yes, in a DR scenario, east is not reachable. So if we go back one slide, right. So this is the DR scenario where so we even the line item 5 where east is available, that's when we really can start garbage collecting resources and healing east as secondary and so on. At step 4, you actually have the application recovered on the west cluster. You don't need the east cluster to recover the application on the west cluster at this point. But to recover the east cluster storage and mark it secondary and resync it from the current primary, which is west, all that happens once east is available. So disaster recovery testing, we're not necessarily switching off east cluster and moving the workloads and as failing over the workloads to the west cluster. If we are testing it from an ability for the application to run and use the data, then the relocate can be performed as the disaster recovery, as the DR testing during the DR testing phase, because you don't want to lose any data during DR testing phase. You need to ensure that there are no further IOs on east and that the pods and PVCs are wound down before you actually move the pods and PVCs to the west cluster for testing. So it's a relocate. That's why we added calling it relocate rather than fail back, because fail back denotes going back to east, whereas relocate is you could just relocate from east to west, west to east as many times as you want. And you really fail over when there is a disaster. But that may not satisfy all requirements. That's why I'm a little hazy on whether DR testing should involve data loss or not.
Oh no, it shouldn't. I mean, that seems pretty clear. DR testing can involve downtime because you have to take things down, do the final copy of the data so that the secondary is fully in sync with the primary, and then bring up your app, which can be shrunk to as few as, a couple of seconds of downtime if you're fast, but it's unavoidable some amount of downtime. I like the way you're thinking about, relocating instead of failing back and being able to move back and forth pretty freely. I'm still scratching my head about the PVC creation and deletion and the way that the selection of the location of the secondary. So when it sounds like in this design, when I'm on the east cluster and I create my PVC and it's of a type that's supposed to get replicated, automatically a secondary will also get created implicitly. I don't have to do anything. But if there's more than one candidate for places for the secondary to go, how is that decision made?
Is the replication fan out or chained?
I mean, in all of those scenarios, like in just a one way, peer-to-peer replication, you could have multiple options for places to replicate to, even within the same site, right? You could have multiple devices or multiple pools of disks, some of which are fast, some of which are slow. All of those, all the storage class type decisions where you would like to give people control over where their data ends up for performance characteristics, reliability characteristics, etc. You want to make those decisions on both the primary side and the secondary side, right? So I'm trying to, because it's implicit here and the PVC is created after the fact. So by the time the PVC is created on the secondary, the data already is where it is. There's no scheduling decision to be made for that volume. It's just give me the volume where it is now. So the scheduling decision was made all the way up front when you created the original thing.
Right. So this is where I see the replication class playing in, where I'm going to have to extrapolate a scenario here from what you're saying. So you could technically replicate from east to west, where the volume on east is on fast pool and volume on west is on either slow or fast pool. That is the target choice. So I would look at it, I would offhand look at it as volume replication class parameter. So when you establish it, it says it kind of says replicate this to slow on the other side. Volume replication class A, and volume replication class B is replicated to fast on the other side.
Okay.
And,
yeah, I mean, so that could work. That this is another situation where when we designed something similar, we opted to just create PVCs on both sides so that the ordinary storage class scheduling algorithms could run on both sides to pick the locations for the two volumes. And then once the two volumes existed, then we establish the relationship. But if you want to encode it all on the primary side and then do it implicitly, it could also work. So, all right.
I think what you're asking for, Ben, is somewhat the orthogonal problem. But basically,
well, no, I'm just comparing this to how we actually did it and tried it.
right.
Because there's some interesting differences, but for the most part, this is very similar and seems to go down the same path. So I like it.
I think the main difference is that, let's say in the Trident scenario, application owner decides, where to which cluster to fail over to. In this scenario, it's the same thing. Instead of just deploying the application, you first deploy the VR, and based on where the VR gets deployed, that's how the application gets deployed there. So it's one extra step. You have to deploy the VR first, and then once the VR is set up the infrastructure for the application, then the application can get scheduled. But once the VR sets up the PVC and PV for the app.
Yeah, in the PV case, the PV has to be set up first, yes. But if we go VR cookie based and we do a PVC with the data source, you can just bring the app in PVC first, and the PVC will never get provisioned because the data source it points to is not yet created. So you can have VR coming in first, in which case when the PVC is created, it won't fail provisioning, or you can have the VR created later and the PVC comes in and keeps failing provisioning because the data source is missing, which in this case is the VR.
So can we revisit how this plays with groups again? Because I've been thinking about all of this in terms of one PVC. So you're saying if we had a concept of a group, what would change?
Okay, so okay, sorry. Okay, fine. I'll talk about something before this. You were talking about PVCs on both ends, primary and secondary. Sorry, yeah, PVCs on both ends, and then in the Trident model, I was just curious there as to how do you deal with stateful sets, or how do you deal with? I mean, there are so many operators out there right now who create PVCs quite dynamically. I mean, they don't even expect for example, the CrunchyDB PostgreSQL operator.
Are you talking about how you deal with them on the primary side or how you deal with them on the secondary side?
How do you? No, the primary side, either other operators create the PVC or the user creates the PVC, or the user scales the stateful set, and hence PVCs get created.
Yeah.
That's fine. That existing cube control plane handles that. But then I guess what I'm asked, I think it's equivalent actually. In the wall rep case, you'll have to create wall rep for each of these PVCs, whereas in your case, you'll have to create PVCs on the West cluster for each of these dynamically appearing PVCs and then tier them.
At some point, yes. So the idea is the PVC can be created with no replication relationship, and it can just be an ordinary volume. And then after the volume is created, you can decide, oh, I want to mirror that one, and you create the necessary objects and you create the secondary PVC and the necessary objects to tell Trident to do its thing, and then now you have the PVC is there. It's receiving data, but you can't actually use it for anything because it's not writable. You can attach a pod to it, but it'll come up and all the writes will fail. So you have to basically wait. Now, if your app is a stateful set, it would get trickier because in order for the secondary to have a relationship, you do have to create a different object before you create the secondary PVC, so that it knows not to create an empty PVC, but to create a mirror PVC on the secondary. And a stateful set, it would not work well with that. So I guess I'll have to think through what exactly that would look like and how we could potentially deal with it, because we probably don't handle that case very well.
Okay, and now I'll segue into volume groups.
Okay.
The way I see volume groups playing here is that instead of the volume replication data source being a PVC, the volume replication data source is a volume group. The one that Jing's working on, the volume group specification that for snapshots that's being worked on, right? And So now what happens is newer volumes, PVCs could be created, added to the volume group, removed from the volume group, whatnot. But the volume replication acts on the volume group, just like a snapshot would act on the volume group and snapshot all PVCs. So it would, again, assuming that the control plane communication happens from the storage east to storage west, create appropriate mirror replication copies on west based on replication class parameters. And when you go to west, the volume replication resource is created again. Okay, so the PV model works, but then the cookie model we'll have to kind of see. Okay, it will anyway again get a cookie to the volume group. So when the volume replication is restored on or created on west, it'll have to promote or demote the volumes based on primary or secondary roles that we assign to volume replication resource on west, pointing to the volume group, which will come in when the app is deployed, just like the PVC comes in when the app is deployed.
What if volumes are added or removed from the group? So are you handling that dynamically? Because in this case, it sounds like you're dynamically trying to figure out what you do on the remote site, right? So if it's if the group member changes, well, how do you
Right.
handle that?
So if the group membership changes from add or a remove, I'm going to, this gets storage specific, but intent would be that, so there are, the question, yes, the intention would be to handle it dynamically, yes. But the question really is whether the storage systems can handle it dynamically or not. For example,
Storage system, well, so this is basically like in the current, the cap for the volume group where we do have APIs for you to add a volume to a group. So let's say user does that. Or are you saying once they start this replication, they can't do that anymore? I guess I was trying to figure out like what's the, what are the steps?
they should still be able to do that. And if the volume group changes, and like it gets a new volume or gets an older volume removed, the replication for the newer volume is triggered, or the replication for the older volumes removed, is how I see it. Why
Okay,
is it so whatever rules apply to the volume group should apply to a volume replication referring to volume group as the data source.
Mhm.
It shouldn't change.
Okay.
So basically the short answer for volume group is that the volume replication would reference either like the cookie, once the backup is done, either references a PV or a volume group, right?
Yeah.
And the information encoded in the cookie is used to either restore or to set a PV or a volume group as the primary, or which is a bunch of PVs.
Yes. That would be a good summary. Yes.
So like we haven't talked much about the cookie, but the cookie is more like some kind of random text that is, I guess it can be a label or annotation on the PV or a bunch of PVs, right? That can be used to identify, you know, a single PV or a bunch of PVs, right? Is that how you implemented it?
The grouping?
No, the cookie here implemented. Is it implemented
No,
as a label
cookie,
or?
So we did not implement the cookie. So we are transferring PVs. We are
Okay.
transferring PVs across clusters. So with the assumption that the CSI volume handle is immutable across these two clusters, and so it'll be able to map back to the original volume. So that's what we're doing currently. But that's not user serviceable simply because it's a cluster scoped resource. And definitely not true for all storage providers that across east, west, or across different storage clusters, the volume handle is readily reusable. So we don't want it. So we've not done the cookie stuff. Cookie stuff is kind of hand wavy.
I see. Okay.
Yeah. So, okay, but then after having said that, and to answer, to elaborate or talk more about what you observed, I'm not looking at, I'm not thinking labels and such. I'm more looking at status output of the volume replication resource to actually have the cookie.
Hey, I'm sorry to interrupt, but we only have 5 minutes left. And we do have another thing on the agenda. So looks like we still did not finish this. We probably should bring you back in another meeting.
Yeah, sure. I think we may need to start discussing this in the Slack more and
Okay. Yeah, that's fine too. So we do have the DP Working Group does have a Slack channel. We can definitely do that. Then we can decide whether we want to have another meeting or not.
Yeah, because I'm kind of out of slides. So
Oh, okay.
anyway, thank you, and I'll hand it back to you.
Okay, yeah, a great presentation. Thank you. So then, okay. Xiangqian, can you talk? Xiangqian, he cannot unmute himself. Okay, so let's see, what
Maybe
is,
double muted, maybe?
I don't know what's,
Triple muted?
I don't know what's wrong. Okay, so let me see, let me try to share then. All right, so basically the other issue here is this this issue. Hey, who added this? Can you talk, please? Or add your name? I don't know who added this.
We discussed this issue a few meetings back,
Right.
and I think like Griffiths was probably like, if I just wanted to check if there's any update here, if we were able to find the bug, like why the backup is not happening. I think we like a few meetings back we had this in the agenda as well.
Right. I think probably because of holidays, I've not seen any
Right.
update on Grant. I just pinned him. I think I have not
Okay.
got a response yet, but I will see if he can. He said he will get back to this. You see
Right.
here, I just said he's hoping to looking into this again. So I assume now after the holiday, he should have time to look into this. So I'll ping him again, make sure that he
Sure.
can.
Yeah, thanks.
So
I just wanted to bring
don't
it
have
up
this.
again.
You don't have this first issue anymore, right? The first issue, which is the object being updated.
I think the issue was the second one itself,
second one. Oh, okay.
which we
All right.
faced in the first place, not the first
Okay.
one, which we observed.
Okay. All right. Sure. But the backup should be successful, right? It's or in your case, you run into issue that it cannot get successful.
The backup was not like the exponential backup thing was not being honored
Okay,
properly.
okay, I see. All right. Okay. Yeah, I'll ping him again.
Sure.
Make sure that he.
Thanks a lot.
Yes. Thank you. Okay. Then looks like that's the last issue we have. Anyone else? Do you have anything else you want to talk about?
Since we have a minute left, I just wanted to point out to Ben about the model that Shyam presented, right? Where we don't create the PVs on the other side. While this talk was primarily for async replication, but when you apply something similar for sync replication, where the storage is stretched, then there are two Kubernetes clusters with a stretched storage backend. Then the model is, you don't want to create PVs on the other side for that case. Then PVCs, then it'll create two dynamic PVCs, right? So I don't know how you handle that sort of model of creating PVCs on both sides for a stretched storage cluster.
Well, even if it's synchronous replication, it's still the case that you can create one unreplicated volume and then decide to replicate it at a later time to another volume.
Oh, if it's stretched cluster, I think you should just have one, right? If it's stretched, basically it's like one cluster.
Correct.
Right. I think that's different. I think this one is not.
I'm sorry. What I mean is the storage cluster is stretched, but there are two Kubernetes.
Oh, okay.
Yeah.
Okay, then you still could have two representation. Okay, I see. So,
but I mean, the decision to add a new replica to some sort of replicated volume, in principle, can be done at any time.
Sorry, I have to join another meeting.
Sounds good. Yeah, just wanted to bring that up. We can continue that later.
Yeah, sure. Okay, thank you. That's a good discussion today. We'll continue at some later time. Thank you. Bye.
Thank you.